It's just that we're gonna.
Okay.
I really liked the recursive swing. That was great.
It's kind of cool.
Yeah, it's
isn't
really
it?
fun. It does that all the time.
And
No
doesn't even
one's,
crash.
can you move it over just a little bit more?
Yeah, of course.
Right.
I can.
Perfect.
Wow, it's almost like we have like an actual presentation set up. It's almost like they calibrated the projectors right. That'd be weird.
You can, yeah, don't calibrate.
No,
It's false.
false.
Doesn't work? Don't change anything.
Don't push buttons.
It
Buttons
works
are
now.
scary.
Buttons will make it not work.
No.
This is one of those scary proprietary undocumented setups that you really just want to be thankful that it's working and stop asking questions.
Press all the buttons.
So, okay, the other day,
Do that
I
in
was
your
helping
workflow.
Elsie with some of her CS homework. Turns out she was using G++ because it was in C++. Turns out I hit a G++ bug
Whoa.
because shell runs an ancient version of GCC.
I believe it. And they never patched anything ever because they're terrible people.
So I was like, hey, mess with this unsigned long, and now all of your signed longs don't carry the right thing anymore.
What? Okay.
Yeah.
So,
On
yeah.
the flip, or
On flip, yeah.
that's why we have to compile everything on flip because
GCC.
everything is old on flip.
You've heard about the original C compiler backdoor, right?
No.
So Richie and Kernighan wrote the C compiler, right? And they go to give Richie an award in the 80s. This is like, it's been like 15 or 20 years since he wrote it. He says, by the way, I slipped the backdoor into the compiler and it's still there. You guys, no one knows.
Oh yeah, because every time it would
Because,
it would detect whether it was compiling itself, and if and only if it was compiling itself, it would put the backdoor back in, right?
yes.
Yeah.
So
That
it
one.
only put the backdoor when it compiled itself, and he compiled the first two, and then took the code out, so no one ever saw the code. So he just said, "Oh, I bootstrapped a compiler for you. Just compile the compiler with my compiler."
Yeah.
It
And then when you
only
compile the compiler with his
adds a
compiler,
backdoor into the compiler if you're compiling with his compiler to hit the original one. So every C compiler after that had a backdoor.
Wait, what?
Kernighan and Richie trolling the world.
Yeah.
Open source
So
is cool. We get
basically,
folklore.
he wrote the original C compiler, right? They go to give him an award 20 years later. And by the way, every C compiler in existence has a backdoor. I wrote it. And it turns out it was a backdoor into a C library for a logging function.
Oh yeah, because so
So if you invoke the right magic, you just get on that logging.
That's disgusting of you.
I know.
so I'm
This is
gonna
a word. It's the only thing except for the word. It's not like thank you guys. This is
It's
like
like, by the way.
I'm so honored. It's like
Yep.
by the way, you guys are all.
I'm gonna put on my talking to groups voice now, and we can kind of get started. For those of you who were able to catch the story time about GCC bootstrapping itself, a really good question was asked earlier, which I didn't answer to the group. What actually is bootstrapping? Bootstrapping refers to pulling itself up by its own bootstraps. That's how you fly, you know? You can pick something up, so you just pick yourself up by your shoes, obviously.
If you ever tried, it's really hard.
It includes the way that an operating system boots. Like, how do you go from powered down hardware to a running system, which we'll talk about in a DevOps Bootcamp talk. Or how do you compile a compiler? That's bootstrapping. Anyway, somebody erased my IRC.
Oh, sorry.
Okay, so I was gonna do a real quick review of IRC for those of you who might be struggling with it, just to get the model of it right in your head. You've got your laptop, and in your laptop you're running SSH or PuTTY or something. And then over here we have shell.ownit. It's a server that lives somewhere, maybe in the data center here in Kelly, maybe in the basement of Milne. It's a server that OSU runs for us. And inside of this, we have a screen. The screen will keep running whether or not we're connected. Normal programs, if you start them and then close the connection, that program will stop. So if you started WeChat if you started WeChat outside of your screen, just normally on a remote server, and then you close your connection, that WeChat's gonna die. But if it's in a screen, it won't. Screen and WeChat. And then we have Freenode that you're going to connect to from your WeChat instance. And there's several channels in there. So from PuTTY, we go to Shell, and we set up our screen, and we set up our WeChat, And then these are just going to stay connected to Freenode, because then we connect to Freenode. That's your /connect, which the exact wording for all of these are in the slides. Could you guys sit in chairs? Because I don't know if the people behind you can see. And then you're gonna /join into whichever channels you want to be in. And then even if you break this connection, this whole side of things is still in place, and your WeChat is recording the things that people say in those channels, even while you're not connected. So now if we connect again with screen -dirc, that's a command that you run on shell to get back into your screen. And once you're back in your screen, you'll see your WeChat, and it'll still be connected, still be joined into the channels just like you left it. Does that make a little bit more sense? Kind of, sort of. So again,
Totally okay if it doesn't.
it's okay if it doesn't yet. We'll go back over a lot of this stuff because I realize that today has been a real fire hose of information for you. So with that little piece of review out of the way, I'm going to hand it over to Jordan to talk about version control with Git and GitHub.
How's everyone doing? Good?
Tired.
Cool. Okay, you guys are still awake. That's good. Yeah, I'm talking about version control and Nano, kind of. Nano is a text editor. How many of you have heard of Nano before? A few? Okay. It's a text editor. I'm going to be honest, I actually don't like Nano, but it's easy to teach and it's simple. We're going to talk about other editors that I think are a lot better later, but they tend to be a lot more complex. So we don't want to cover them right now. We're also going to be talking about version control, which I'm going to get into Nano first. So it's kind of a summary of what we're covering. We're going to cover Nano. We're going to talk about Git, which is a version control system. We're also going to talk about GitHub, which is a website that is really cool and releases Git, and you'll find out more about that in a bit. So Nano, you can start it in your terminal by just typing Nano if you have it installed. If you don't, you have to run sudo yum install Nano, which I believe, no, actually, I missed the slide. If everyone wants to try and run Nano, though, let me know. It probably won't work for us. Yeah, cool. So sudo yum install Nano. I'll write that up on the board. Yeah, can you write that on the board for me? So when you open up Nano, you'll get a screen like this. Up here, I was typing some stuff. And in Nano, you can just type. You can use the arrow keys to move around. And you can see down here, there's some controls that you'll see. The caret symbol just means hold control while pressing the key. So for example, it's kind of hard to see, but it says Control O is write out, that means save. So you can Control O to save, and then say save to this file name, you can enter. Control X exit. Those are honestly the only two I really ever use now. But I can give you guys a quick demo of that. So okay, so you can see I'm typing, and you use the arrow keys to move around, and Control X exit. Oh, is it cutting off? I'm sorry. Let me shrink that down a little bit. How's that? Okay. And then, okay, so I can hit Control O, let's say file name to write. You can call it file name, it's really creative. Enter, and it says wrote 4 lines. It saved it for me. Control X exit. That's Nano really quickly. Yeah, we can go over more of it later, but feel free to play around with Nano. Sudo yum install Nano if you don't have it installed yet already.
Those are all lowercase, by the way.
Yep.
And you can look at the man page too to, to find out more about it.
So you type man nano, and it will give you. You guys covered man pages in the last session, right? Yep. Yeah. Okay. I wasn't here for it. Sorry. So yeah, that's Nano quickly. We can talk more about it later if people have questions. So on to version control. Version control is bar. That's the title says. This is an XKCD that there's kind of a running joke of like the more commits you add in version control, where commit is like a snapshot of something, the worse your commit messages get. It's funny. If it's not funny now, it might be funny in the future, or it might just be kind of sad.
It'll be hilarious in like 2 weeks.
So this is one of my favorite comics. It's from PhD Comics. So this guy's writing his PhD final thesis, and he submits it to his professor, and then he has to write a revision, because of course there are corrections to his final thesis. And then now he's in revision 6 with more comments, and then in revision 8 with more comments, and it just gets huge and escalating and hard to keep track of because there are so many copies, because the professor keeps making edits and he has to keep making more changes. And at the end it's like a giant mess. Revision control can help with that. And that's kind of the entire point of revision control, is to fix situations like this. So, like I said, one of the key ideas in a version control is a commit, which is like a snapshot of your code in a point in time. It's kind of like taking a picture. There are some different versions of different types of version control. Some of them are called centralized version control. There's things like SVN, CVS. You might have heard of those, or you probably hear of them in the future. Git is decentralized, which means there's no super special server. Whatever you call the server is the server. That has some nice features. We probably won't get into those today, but you'll find out about them in the future. So today we're just going to talk about Git. Git is pretty easy to learn, but it is also very technically deep. If you want to dive crazy deep into it, it gets really complicated. We're just going to stick with the easy stuff for now. Feel free to ask lots of questions about it. I love Git. It's widely used in the open source world in most circles. CVS is basically completely died out. There's only a handful of people that still use it. SVN is becoming less and less common every day. Git and HG, which is Mercurial, are fairly common. Mercurial is kind of lost against Git. Git's the most common nowadays. Git was written by this guy. Some of you might recognize him. It's Linus Torvalds. He wrote Linux. He used to use a version control for the Linux kernel that was not Git, and it was proprietary, and eventually the company that was writing it stopped. So he wrote Git because he wanted a version control that actually worked the way he wanted it to. And it's based off of, the original was called BitLocker, I think, or BitKeeper, something like that.
Yeah.
There's a definition of Git. I have no idea why Linus decided to name it Git.
He named it after himself.
Yeah.
Oh,
it's a self-describing name.
nice. That is very descriptive of him.
Yeah, so.
If you don't know, Linus is very famous for being a complete jerk, and he recognizes that he's a complete jerk and doesn't care.
He is kind of where we get that stereotype of engineers being all practicality and very little feelings, probably.
Yes.
So if
He
you want
reinforced
to work on the Linux kernel, you have to interface with him, so you better have a thick skin.
Yeah, that's actually what he tells people. He says, just grow a thicker skin.
Yeah, he will critique you in a very mean sense.
Yeah. Some people really don't like it. But a whole other thing. So for setting up Git, run sudo yum install Git, because it's not installed by default. We have to do that. And then we have some Git configs. We'll do that in a second. Because let me know when everyone, like, raise your hand when you've installed Git. You're young. Just keep it up for a bit. Okay, so a couple people. Cool. Has anyone used Git before in here? Okay, same people. Cool.
Yep.
What have you guys used Git for? Just classes on your own? Cool. Have you used GitHub as well?
Yeah.
Okay, cool. So you probably know most of what I'm going to talk
And
about
you'll be able to help people as they get set up.
How about you guys in the back? Raise your hand. Research? Cool. Okay. Have you used any other version control systems? Okay. Did you like SVN? Okay, fair enough.
Is anybody here old enough to have been subjected to Beaver Source back in the day? It was a
I was subjected to it once, and then I ran it for a while.
Implementation of some version.
Yeah. We got to kill it. It was nice. Nice. I didn't know you did. I feel bad because I disappeared and I came back and he was dead. I really wanted to be there. Cool. Everyone have Git installed now? Sudo yum install git. A few more people? Yeah?
If you don't have it installed, raise your hand.
Yeah.
Okay.
Cool.
Are there any problems or is it happening? No, it's
Just
Okay.
taking a while.
We're just waiting for the mirrors and the network slow.
Got a question back there?
Oh, your borrowed laptop. So I would recommend just following along with someone who can install locally.
That's Git, right?
Yeah, man. What was that?
Yeah, you're good. You already have Git.
Really?
So yeah, type man
Who does
git.
Git?
Yeah, he's,
Is this your local shop? No, Alfred, it's your local. I said, look, looks like you know the package manager that's a good thing. That would be happy. Yeah. Yeah.
oh, so you're not actually recording.
I want to type that big space, so. If you were in your beginning, package manager would be something. Here, anytime you
Now, yeah, that's your question. So you type major space, that's H. Yeah.
you have So you want to go directly where you have your
Yeah. So, shell says your yeah. Yeah. So on the paper, the default is always paper. The box is just called core.editor. So we're going to talk about that in a second. Exactly. So I remember everyone said it's Nano, and we talked about Nano, and I don't remember it right away. If you have an editor you can use, you don't have to set it to Nano. So some of you probably started typing these commands. These are just going to set some nice configs for us. So the first one just sets your username. When you make a commit message, it'll put your username on there for you. Second one sets your email. You should put your own email address in there. The third one sets the default editor for Git to Nano, which is the editor that we just talked about a few minutes ago. It's the simplest one. Git actually does not default to it normally, which is why I have to set it in or yeah, which is usually. If you have another editor you prefer, you can not use Nano. That's really cool.
And the editor is going to be used for writing commit messages. So you make changes to your code, and then you say, these are the changes I made. And that's basically how you tell people the differences through versioning. And that's the editor you're going to use to make those changes, to write the message.
Yeah.
That's
it opens the text editor for you. And it'll automatically open one, so we want it to automatically open Nano. That's what we're talking about. Has everyone run the config commands, git config? It's working? Yeah, it's
They would not run the config commands.
We had a few problems with people getting their virtual boxes back up.
Okay. Yeah.
The short version of how to get that in is you go to the same directory that you have your vagrant file in, and you type vagrant up, and then you SSH to it using whatever means you did before, either copy or just vagrant SSH.
Vagrant up,
in CMD.
vagrant SSH.
Yeah.
And it's got to be in the same directory as your vagrant file.
And you'll know you're in the same directory if you type dir and there's vagrant file. And that's
If you're on Windows.
If you're on Windows.
Yes.
If you're on Linux,
Type ls.
you should know what you're doing.
Actually, there works on most of them.
Does it?
I didn't know. Okay, cool. This is just some link.
If you have problems, raise your hand.
Let's find out. Nope. It's apparently a core util. Today I learned. So tell us.
No, those are shell.
Oh, because CDs are built in, yeah. Yeah. Assuming, yeah, that should. Huh, okay. That's really weird. They're not even hard linked. Yeah, they're not similar, they're not hard linked. Yeah. It used to be actually like, so BusyBox still does this in some cases. BusyBox is actually just one binary, and depending on the name you call it, it does different things. So you make one binary, 6 ways, you make one binary, and you hard link out every name you need the utility for. That's pretty cool. Now they do symlinks because people like to put user bin and bin in different places. Symlinks are easier than hard links. Does anyone still need help? Who hasn't gotten help yet? Okay.
Okay, does anybody not have Git working yet?
Or install it in the config. Okay. So the way you initialize the Git repository is go to a directory and you type Git and it. That will set up the directory for you. And it will do some fun things. So I'm going to show you guys an example here. First, I'm running mkdir, which makes a directory because I don't want to run it in the one I'm in. So I'm calling it test. And then, so you can see now there's a directory called test right here that I just made. So I'm typing cd test to change into that directory. Now I'm in the new directory, and I'm going to type git init. And you see it says initialized empty Git repository in the directory I'm in. That's it. Git init's really simple. So now I can run Git Status. Git Status will tell you where you are and what's going on. So it says on branch master, master is the branch name. I don't need to worry about that too much right now. Initial commit, I have no commits. There's nothing to commit. So you can use git add to track. So when you're in your local directory, let's, I'm going to make a file, call it nano. I'm going to call the file Jordan because that's my name. Hi. So now I have this file named Jordan, and it has a line in it. Yeah, sure. Yep. There we go. So now if I run git status, you'll see it says untracked files. That means Git is not currently tracking this file. And if I go to run git commit, it won't commit the file. It's untracked. So we can start tracking it by saying git add Jordan, the name of the file. So git add file name. And now if we run git status again, it says changes to be committed instead of untracked. New file, Jordan. I'm adding a new file, not changing an existing file. And now I can make my first git commit. But first I'm going to run that config line that I told you earlier, so I open nano and not something else. Okay, so I do git commit. You can pass it -m and the thing in quotes to add the commit message, or you can just run git commit with nothing else, and it will open up an editor for you. So I'm just running git commit without the -m, and it says, please tell me who you are because you did not give me a user.name or user.name. Git really wants you to do that. So I'm going to do that. Git config global user.name. Yep. Okay. Now that my config is set up properly, I'm running git commit. Haha. Thanks for catching that. Well, now I have to run that one again. Turns out typing in front of people is kind of hard. Now I'm going to run git commit because my config is set up properly. And hey, it opened nano. You see here it says it's editing this file called commit edit message. You can see here this looks a lot like what we saw with git status. So here's a little bit of meta. It says, please enter the commit message, which I type up there at the top. I'll do that in a second. It's an initial commit. It's the first commit. Changes to be committed. It's adding a new file named Jordan. So I'm going to type a commit message. This is my first commit. And I hit Control-O to save. And it's prompting me the file name that I really want to write. You can just hit enter because it knows the file name. It does it for you. Wrote 10 lines. That means it's saved. Control-X to exit. And now the output says master. That's the branch I'm on. We'll talk about that in a bit. Root commit just means it's the first commit. We don't need to worry about too much. This 46CFEC1 is a hash. It's Git's way of identifying commits uniquely. We can talk about that more in a bit. And with my message, this is my first commit. It says one file is changed. There's one line inserted into the file. It says create mode. That's some permission. We'll talk about this later. Jordan, name of the file. So has everyone been following along and running these commands for themselves? You don't have to. We'll have some time for that in a bit. Yeah, now I have a Git repo with one commit. We can run git log, L-O-G. And hey, there's commit. This is the unique identifier. It's kind of long. Author foo. So my name is Foo. And my email address that I added has a date. So it's Saturday, October 11th. This is my first commit. It's my commit message. So now I'm going to change my file because my file is really boring. And another line. I'm going to write the file because I added another line. Actually, I added 2 lines because I added a blank line. Control-X to exit. We run Git Status again. You'll see changes not staged for commit. That's just like untracked. It's the same thing. Modified Jordan. It's in red because it's not being tracked. It's not tracking the changes. So you can see it recognizes I've modified this file, but I haven't added it to be staged. So I can run git add Jordan again, just like I did before. And if I run git status again, now it's in green, changes to be committed. If I run git commit right now, it'll add this file to the commit. So I'm going to run git commit once more. This is my second commit. You can see it looks a lot like it did before, but now it doesn't say initial commit. It just says on branch master. This branch I'm on. Changes to be committed, modified, Jordan. Now I'm saving. I'm exiting. We have another commit. Branch master doesn't say the root commit because it's not a root commit. Unique identifier is a shorthand for the full unique identifier. My message, one file change, 2 insertions. I added one line plus some text in another line. And I can run git log again. You'll see now I have 2 commits listed. Here's my first commit. Here's the second commit. It goes newest commit on top to oldest commit on bottom. There's some ways it cannot do that, but we can talk about that later. I run git status again. Nothing to commit, working directory clean. That means there's no changes at all. Nothing I can stage. If I try to do commit right now, you'll see it'll be like, what are you doing? There's no changes. You dummy. Nothing to commit. Working directory clean. Yeah, that is Git in like 5 minutes. That's probably longer than 5 minutes. So why don't you guys take some time now, try and make a directory like I did before. So I'm in that directory. I ran make dir test. I made a new directory. Then I did cd test, ran git init, like I did up here. Nano file name, in order to write something to the file, save it. And then run git add file name and git commit. And yeah, feel free to ask lots of questions.
Yep, and we know Git, so if you have questions, you can ask any of us up here, you in the back, and these 3 people right here, writing around.
And you can always run git status and git log. I will tell you more about what's going on.
Yep.
I run them like a bajillion times a day.
Basically every other.
Yeah, question?
At least.
At least.
Sometimes twice.
We got a question? Oh, okay. So,
Yeah, you had a question for that. You've got it.
kind of a conceptual, like, oh yeah, they're kind of snapshots, they kind of build like each other. Like, this is
Yeah.
why we're doing all these magic words.
Yes. I just wanted to get some fun
Yep,
with it.
certainly.
After this, you can go into, here, I'm gonna freeze
Okay,
the screen on that,
cool.
just so they have the reference.
Good stuff. Okay.
The slides ahead.
Okay, yeah,
There's not much ahead.
there isn't much, and then there's like GitHub.
Yeah.
So I might do the whiteboard.
Okay. Yeah.
Here's a repo that is a Git repository. How do you make that not a thing? How do you make it not a repository?
You need the dot registry.
That's it?
RF, like RF, dot.
That's it? Okay.
Okay. It's asking.
Yes. Yes. Yeah, so we can change things in your repository, and you can get this happen. Add says, make sure, add basically says, I really want this to be so I mean, otherwise, it's useful and works like that. It's a little confusing, that's unnecessary. Okay. Control O for yes, and then just hit enter, and it's out the finally correct. And then Control X. And you can see you have your first command. There you go. Yeah, exactly. So you can be like, I know it's all that in church. And if you quit, you can turn that. Exactly. So like, say you make this one change and you want to undo the change, you can go back to the old community name and undo the change.
So you can do, there's a couple commands, there's Git and Reverse. Which will reverse. There's also Git Reset, which will change the local directory. How do I
So there's a few different ways to do this. Let's see your Git log. So Git hash.
Basically, it's like Git Status. Some other place, so like a server, just go to your server and get full changes from the server. So if you write to commit, just go to the server. You only go to repository that the server needs to share. When you run Git pull, you get this Git. Yes. How do you? Yes.
So
So we're going to talk about Git.
there's a server down Git, which is that.
Traditionally, the way you can get versions is it represents it as a set of changes. So initially you have nothing.
So you
And
initialize
then you add a file. So you just have one file. It will say, in your commit, basically say, since you added this file,
you should be able to
and then say he goes to
So
and something's one line.
the
next
Yes. So the way to do that is to
three lines on it, you change one line, then you make it commit, your commit will say, you need to slide at this new line. That's basically right? And she can pull in your commit on top of hers if she made no other commits, you haven't changed anything, except she wrote his commit.
So we're gonna
It's just completely on top of yours. Because he knows it said, okay, yes, there's this file, has 3 lines, and when you delete this one line over there, and another line. That's how he changed. If you,
you're not in a now maybe
yes. Yes.
yes.
But once you process these in, then you can come up with your file. And the file
one way to look at changes.
Yes.
As long as it's, you both have the same,
Everything
the same history, your commits. We're going to talk about this later. So if you go back to mostly as copy that. Now we've got the same file, same line in the same file, and it's actually different. Server will say, wait, you have same link there. And you just want me to add this thing. Oh, well, if I took your push and deleted this all, we have it 4 times you really so then it's only this changes. And it'll say, Joe changes the same thing. And it will and that's, it does that because sometimes it's very complex to figure out if you want your change, if you want this change, or this change based on
And
code.
sometimes it's a piece of code that. Yeah.
No, it's actually been a pretty good day.
Okay, it's like,
No,
Jesus.
and
No appreciation.
Oh, yeah. I realized that about 3 yeah. Like,
Okay,
Before we go back, is everyone good?
has everybody been able to run Git commands, even if you're not quite sure what they mean?
Who has not run Git commit and wrote a commit message? Anyone? You. Okay.
Okay.
Ian's gonna help you. We're gonna gather back in just like 2 minutes.
Okay, cool.
And
Yep.
Emily's going to explain some more awesome stuff with pictures. So.
I like pictures. I like pictures a lot. They're the only way I can learn things.
Yeah, I think yes. Yes. I actually they're in a branch that branched.
Irony.
Because I had two branches in J. I merged in one. I did it because I like pull requests, and then everyone was like, hey, what's master guys, that's great production.
I feel like we have a workflow with pull requests.
We have that, except some people are good.
The thing is, or that I might have heard about, is defining what constitutes sufficient literature. Like, 2 students, 4 articles in my work, plus 1 student, something like that. I feel like if we
So I like that because it's well defined. I like it. I don't like it because I think the vision situation where having something well defined is not a choice.
certainly, so something like, most of the time, this, when in doubt, if it's a really big change, if the words you're gonna write stuff, then get the right person. And I think use your better judgment, but that's not a definition for this is sufficiently looked at for words on trivial changes. It's really important to have in order to get this workflow. That's why it works.
I agree.
Yes,
The
like,
only problem though is we have already had, like one case we had this summer where like a trivial non-breaking change. There should be a no even the chef said, someone else reviewed it like 30 seconds later said, yeah, it totally doesn't do anything. He hit merge and broke all log. Because they are both out at the same time. So, like my use, I would like to do something where like simple, a simple change could be 2 students plus 1 undergrad, right? Or 1 full-timer plus 1 undergrad. Complex change requires at least 1 full-timer plus 1, plus no 1 minus 1. But differing between a complex change and a simple change is not necessarily based on how much change there actually is. Yes, because online can break everything, or it can do almost nothing.
yeah, that's hard to do. Exactly.
Exactly. And part of that is like we do have these things in the spring. That's okay. So maybe I just need to let it go and think it's okay.
I feel like this is one, we just need to be like, okay, we follow the workflow, kind of chastise guy conduct, but at the end of the day, it can't be a fine fault, it's got to be a yeah,
Yeah, that's how it's like it was a, well, we know you guys didn't think that was a making change. Please remember that making change.
So shall we put back in rubbish?
Yes.
Okay, so I'm gonna pull it back in. If I could ask you guys to kind of pay attention up here instead of helping one another, it's great to collaborate on stuff. But I'm going to explain the same thing that Jordan just did in a totally different way, because there are a lot of different ways to teach this, and some of them will work for some people's learning styles, and others of them will work better for other people. So basically, the things that we want out of Git are, we want it to be able to track all of our changes. We want to be able to undo any given change, and we want to be able to work with others on our projects. So the way that Git handles this is it takes your repository. Your repository is just a folder. The way you can tell if your folder is a repository or not is you ls-a for list all the files in here. If there is a .git directory available, then it's a repo. If there's no .git, then it might be a repo if there's a .git anywhere above it in the tree.
A really simple way to immediately tell if you're in your repository or not is run Git Status. If it says something like there are changes or there are no changes to be committed, that means you're in a repository. If it says, I have no idea what you're talking about, this is not a repository, you're not in a repository.
So a commit is a description of what changed since the last commit. You have that bootstrapping problem that we keep coming back to, and so the initial commit is kind of special. The initial commit is just all of your files.
The initial commit can also be called the root commit. If you know what a tree is, it's because it's the root of a tree. If that made no sense, don't worry. We'll talk about it later.
Then when we make another commit, we make some change, we git add the change. So Git has roughly three states that a file can be in. A file can be untracked. This means it doesn't exist anywhere in the history. Git doesn't follow it. I mean, Git can see that it exists when you're trying to look for things to add, but Git doesn't know about its history. It can be staged. That means these changes are ready to be put into a commit. One cool thing about commits is that you can have changes to several files. Like if you change a config here and add a thing there that relates to the config, and that's logically one change, that can all be in one commit. And that makes it easier to undo or redo a single action.
You stage things by using git add.
Yes.
So when you guys ran git add and then the file name, you moved it from being untracked or unstaged to being staged and ready to commit.
Mm-hmm. And then the third state that a file can be in is committed. So when you run git commit, it takes everything in the staging area and it looks at how they've changed between the last time they were in a commit, which might be never if it's a brand new file, and when you ran git add. This may be relevant if you make a change, you git add the file, and then you go make a bunch of edits. The version that was there when you ran git add is what's going to go into a commit. And then, so we make some changes, and then we make another commit. So what's in this commit? There is a date, an author, that kind of thing, a hash of all of the changes, and a pointer to the previous commit. So it goes, so you go back there and you make it match that, and then you do these changes. That's how you get to this thing.
Froze it though. Yeah, let me.
Yeah, you can unfreeze.
Go ahead.
So the commit has various data associated with it, and that pointer back. So if you've done a bit of math, done the discrete math class, this is going to start looking a bit like a tree, because you could, via various ways that I'll talk about later, have two commits that have commit one as their parent. If we're doing a test of something, and so we want to go from here, that can have a parent, and you can have another commit with that same parent. This relates to branching, which I'll get into in a bit. But basically, everything can be tracked back up the tree to that initial commit. Now, why do we care? Why is this useful? One of the really big things is it gives us security because of the hashes of the changes in each tree. If two different people, okay, so now that we're talking about distribution, need to set the terminology. There's what's called cloning a repository. You guys each made a brand new Git repository, but that's not something that happens very often in a project. Git init will only be run once, even in a really big software project, because everything else is going to build off of those initial changes. So even when you fork, even when you change, even when you make your own copy, it has all of that same history as you had originally. So let's say we just got two commits right now. Let's say these commits live on my laptop, X230. And then what's this guy called? What's this laptop called?
This laptop is called OSU, so we'll call it DOBC.
Okay, and then let's say that I'm working on my laptop, and Jordan is working on this laptop that's named DODC, and he wants a copy of my repository. So he's going to run git clone and then a path to my repository if I have it exposed correctly. And that's going to make a copy of all of the files and all of the history. And now the second computer is going to have commit 0 and commit 1, and they'll be just the same, and they have the same hashes. Now, if I decide to be a really bad person and change what was in commit 0, then its hash will change, that one's hash will change, and if you try to pull from my repository, Git will be like, hey, somebody changed something. So that's really useful. But let's say I'm not a bad guy. We're just working together on our project. I make some changes in the first file. And he makes some changes in the second file. And each time I draw a little commit like this, we know that you made some edits in your file. You use git add to stage the changes that you wanted. There are flags that you can pass to git add that stage only some of the changes from a file. If you use, let's see, I should write on that.
Can everyone see the whiteboard that she's writing on?
Kind of.
Yeah.
My handwriting is terrible. I apologize. If you use man git-add, that will tell you all the cool stuff that you can do with git add. It will be another fire hose of information because Git has a lot of functionality. But I had some changes that changed file foo. He had some changes that changed file bar. And now we want to bring all of those changes back together. He can go and get this commit. Let's call this commit 1. This is commit 2. This is commit 3. He can apply his changes on top of mine, or my changes on top of his. So you can end up with a tree that looks like, or if he tries to push to x230, then it will say, okay, how far are we the same? And then, oh, this is different. So let's apply this commit onto here. And then you'll have a tree that has all of the changes that the various contributors to the project have made. And one of Git's strengths is it's really, really good at merging. If you've changed different areas within the same file, then it can just look at those change sets and go, oh, these are compatible. I can just combine these changes and figure out what the outcomes should be. Occasionally, it will fail to merge. This could be if you both edited the same line. Like, let's say you're working on a report and you have it in version control, and it's like the first line is report name by such and so, and then they change that same line. Then Git doesn't know which one's correct, and so it'll go, hey user, I don't know how to fix this. You should tell me which of these is correct because they conflict, and that's called a merge conflict. And if you carefully read what's on your screen when you encounter a merge conflict, it will walk you through how to fix it. But essentially, Git lets you apply a series of incremental changes, which are modeled as commits, into a single project. And probably the best thing is if I realize, oh, that change code just broke it and now it won't compile. I wish I could just undo that. Like, how often have you been working on a coding project? You've been like, oh, I'm just going to go try this thing. Oh, that didn't work. Now, how was it before, back when it was working and it's like 2 a.m. or something? Git has undo commands like git revert that will just make it as if that never happened. Now, that'll change the hashes of the ensuing commits because it gets security properties, but that's just fine if it gets your project working. So with that visualization of it as a tree with a bunch of commits, each of which builds on the previous one, I'm going to try to explain how using a centralized repo and how branching works. So let's mention the fact that GitHub exists about here, do you think?
Okay.
And we have slides a bit on GitHub. Let's go with, could we unfreeze, please? Let's actually go with the don'ts first, because the workflow thing and the don't do are important.
Yeah,
Hit the unfreeze button on both.
one thing I want to mention while they're getting that going is that Emily just threw a lot of information about Git at you guys. Don't worry if it doesn't all stick. Our goal for today is just for you guys to get an idea of how to work with Git by yourself. And we can worry about working with Git with multiple people working on the same repository later. We're going to go over pretty much all of this again at some point and more. So if you're feeling lost or like this is way too much information, that's totally fine. We're going to go over it again.
Yep. This is just like giving you an idea of what questions to ask. Like, now you know you can ask, oh, hey, how do I undo that one commit? And you can think of a commit as, this is one important change. So, yeah, there are some don'ts to avoid breaking Git.
Yep. So like we were talking about before with the .git files that Git creates, don't delete those because that's where Git stores all of its information about the repository. And if you delete that, all of Git's history and all of its understanding of it being a repository is completely gone. So if you see the .git files, just don't delete them, leave them there. Git will manage them for you. You don't ever have to touch those actual files. What was the point of the second one?
Okay,
You wanna
so
talk about that?
you may have the habit of, here's my report with those changes. You need to stop doing that. There are ways that you can branch to take your work in two directions at once and then bring it back together later if you need to, or just leave them separate. But your repository will get really big really fast if you have redundant copies of the same work. Another thing is that if you have some work that you didn't do by hand, like a PDF that was automatically generated based on some other files, you don't need to commit that because it's not really something you need to save. If you can revert those other files to the way they were at a particular time, then you inherently have that PDF available to you. So you rarely need to commit the output of whatever work you're doing. If you touched it by hand, it should be controlled under revision control. If it just came from a script and you have that script under revision control, then there's no need to waste the space.
For example, if you're working with a compiled language, you would want to store the source code for your program in Git, but you wouldn't necessarily want to add the binary that you compiled to. Because at any point in time, you can just run all of your source code through a compiler and get the binary. And binaries on different systems end up looking different. So people don't commit the binaries, they just commit the source code, which is what she's talking about, because you can create the binary from the source code at any given point in time.
Like how we talked about compiling in the last lesson.
Yep. So if you want to undo something, Git actually provides a lot of really cool tools to help you with that. Git revert is a really awesome one. We're not really going to talk about that too much today unless we have some extra time at the end. But if you do man git -revert, it'll talk about how to undo commits that you don't actually want later. Sometimes you go to change one line and you accidentally change it incorrectly. You find out later you want to undo it. You can do git revert and you can totally undo a commit. It's really cool. But that's something you should look up on your own time or ask us questions about towards the end of this. Don't wait too long between commits. You should always commit fairly quickly and fairly small commits. That's something that may not be apparent why until later, but it makes things really nice down the road when you're working with lots of people and you want to logically separate your commits into as small as possible but still makes sense. So like if you go to add some feature, say you're adding 2 features to your source code, you would make 1 commit for each feature ideally, or maybe a couple commits for each feature depending on how you do it. But you don't want to make 1 commit with both features added at the same time. Because later, if you want to undo 1 feature, that makes it harder. Make commits small as possible.
Like imagine that Git is your time machine to the history of your code. And you can only stop at places that you committed. So in order to have the most power with that time machine, you want to have as many logically separate commits as you can, so that those are like stops that you can stop at and then go in a different direction from there. But at the same time, having like 1 commit for each line that you changed or something is kind of overkill, and having that many stops available to you and your journey back in time makes it really confusing which one you should stop at. So every time you'll get in the habit as you use it more of thinking, oh, this is a time that I would like to be able to go back to later. And that's when you commit.
So one final thing that we want to mention is don't commit secrets. Secrets are things like passwords, API keys, things you generally don't want other people to know. You can eventually remove them from a Git repository, but it's hard and you can't guarantee it. And if you accidentally do commit a password or an API key or something else that should be secret, change it. Change your password, change your API key, regenerate it, and remove the old one. Do both. It's a good idea.
In general, don't commit passwords, don't commit API keys, don't commit anything you don't want other people to be able to see who already see your code.
And in general, getting things out of Git history is disproportionately hard. Getting things into the history is pretty easy. That's a good thing. You'll come to appreciate it as you use it more and more. It's really, really nice to know what happened at a given point in the past. So don't let that bite you is all.
For example, if you commit a password as your very first commit in a repository, and 100 commits later, you decide you don't want that password in the history of the repository ever, it's possible to undo that. It's very quickly becomes non-trivial the more commits you have.
And if you're working with other people, it's especially important because it changes the history, and that sets off the security alarms, because security alarms and warnings will go off anytime somebody tampers with the history. That's one of the things that keeps a version-controlled code base safe. So I think we can
Git likes to, just one more thing I wanted to add is Git likes to not ever change its history. Things that happened in the past should stay in the past. There are times where that's not true, and Git provides tools to get around that. But in general, you don't want to change the history if you can avoid it at all possible. And Git will warn you if you're trying to do something that does change the history. It will say, hey, can't do this unless you really tell me you want to. And we'll talk about that more in the future, probably not in this session. So this slide is kind of fun because it talks about daily workflows, and lots of people have crazy different opinions on how Git workflows should go. This is a diagram. It looks insane, and like no one actually wants to follow that. Some people do, and it actually works really well for a really complex thing. But you'll hear lots of, if you ask people about how they use Git and what they do with Git, you'll get a different answer every single time. It's okay that it's different from how you use Git or how other people use Git. There's not a right and a wrong way to do it.
So your workflow, if you're just working on a small project by yourself, will probably, I'm going to assume right here that you're using a remote repository like GitHub, which is the next thing that we're going to talk about, because that backs up your work.
Sorry. One more. So your workflow will mostly just include these commands to start with. You'll eventually add some more commands, and like git push and git pull, which will interact with remote repositories on servers, like on GitHub. But yeah, it's totally okay to only use Git with these commands. There's nothing wrong with doing that.
I mean, it's really cool if you use a remote repository, because then it automatically backs up everything that you've done. And who doesn't want to have like a free backup of their work when they do something wrong and accidentally lose their .git directory or something?
So now we're going to talk about GitHub. GitHub's mascot is called an octocat. It's an octopus and a cat put together. That's a picture of it. It's kind of cool. They dress it up in different outfits. There's like an Iron Man octocat. There's a Superman octocat. Basically, lots of really cool things. So if we go to github.com, could you write that a little bit bigger? Sorry, it's a little small. I'm going to make this a little bit smaller so we can see better.
There we go, github.com. And then it will be very friendly and helpful and walk you through the steps to create an account.
So right here, you pick a username, you enter your email, you enter a password, and you click sign up for GitHub.
It's really, really cool to use the same username on GitHub as on IRC. That helps immensely. It's possible to change it later, but if you found a nickname that was available on Freenode, it's probably available on GitHub. And it gives you one identity under that handle. It makes it really easy if you're saying to somebody in a channel, oh, hey, I have this thing on my GitHub. They can just find you because your URL will be github.com/username.
So you should all sign up for GitHub now. Do you want to run through the sign up process on live?
I don't want to make a new account.
Okay. I mean, we can always delete it later.
So now, so just you give it the steps. You give it the things it wants, and then you get the confirmation email, and then you click the link in your email.
And then you'll click the sign in button, or it might automatically sign you in when you click the link. You sign in if you want to sign in.
Sure. I have my GitHub is kind of terrifying. don't remember my password. This what? Oh, I didn't put enum. Wow. Yeah.
Remember username and password. That would be really hard problem.
Yep. No, I wouldn't like to remember that password either, especially because that's my real password. Oh, yeah. Okay, so there's me.
Yep. So this is Emily's GitHub user page. You click on your username at the very top right.
I should make it so it's visible. Shouldn't I?
Yeah.
So you have this cool bar at the top right that shows you like your username.
You'll scroll over a little bit.
If I can find the scroll bar, I'll scroll over.
There it is.
There we go.
So you can see it has your username, a little plus, a little like message box. That's for notifications.
I've got a bunch of notifications. We don't want to think about those.
There's a little settings field and a log out button. The important ones for now are going to be your username, the plus, and the settings.
So there is one thing you're going to want to, at some point, not right now, Google for github.com education. Since you all have some form of .edu email addresses, you can get a bunch of free stuff from GitHub.
They like students.
The two most useful things, in my opinion, that they'll give you at the moment are 5 free private repositories. So when you have a prof who's like, don't put your work publicly on GitHub, you can still get all of the benefits of backing it up and collaborating with other students, but without it being publicly visible. GitHub's profit model, it gives you unlimited free public repos for open source stuff, and then it charges for private repos. And when like companies and larger organizations need to keep their data private, they end up paying GitHub non-trivial sums of money to have a bunch of private repositories. So that's really cool because it means that GitHub doesn't have to sell your information or advertise at you.
So who has not been able to sign up for GitHub, does not have an account right now?
Does anybody not have a GitHub account yet? Okay, any problems or just in the process, waiting for the email? Okay.
Okay.
So
we'll pause for a moment.
yeah, or I can just talk a little bit about, yeah?
Is like GitHub secure enough to like privately
So depends on what you define by secure enough. We can talk all day about whether something's secure enough and get nowhere.
Like describe your threat model that you're talking about.
No, don't worry about
okay.
that. So GitHub private repos are pretty good. They're not amazing. They're not bad. GitHub also has what they call an enterprise model, where they basically give you the GitHub code to run on your own server and no one else has access to it. That's much more secure. If you're really worried about security, which large companies tend to be, they go towards that side rather than hosting private repositories on GitHub's main website.
Okay. Yeah, I'm not worried about my
Yeah, that's a great question.
If Microsoft was cool enough to use Git, the world would be a better place.
So I worked for a company that actually, we had, the company owns 6 GitHub accounts and had a private enterprise GitHub set. It was kind of a mess, but we used all different varying sets. We personally, the team that I worked on, stored all of our code for our entire project in private GitHub repositories on GitHub. And we open sourced some of them, so some of them were even publicly available too.
Mm-hmm. And a lot of startups will use GitHub private repositories because when I say what's your threat model, there's this concept in security that the definition of secure enough really varies. So there's secure enough like, oh, my friend could get in and play a prank on me. And then there's secure enough like, this has people's home addresses in it who are wanted by bad people. Better keep it safe, or like this has confidential school or medical records, that kind of thing. Don't put really confidential records in it, but it's sure going to keep your friends from pranking you. It's sure going to keep people from easily viewing your homework if you keep it in a private repo, that kind of thing. So if you have a specific threat model in mind, like, oh man, I have this crazy ex who really wants to find something mean to say about me and wants to like look at my files and is out to get me personally, and has got a keylogger on my laptop, something like that, then you got to take it that like case by case.
There's a famous Microsoft researcher. His last name is Nickens, is it?
Oh yeah.
Yeah, he wrote a paper basically kind of explaining like whether or not you should really be worried about security. And his answer was, he talked about the Israeli Mossad, and he came up with a verb called Mossaded, which is where, like, if the Israeli Mossad is after you, they're probably going to get you unless you're really super concerned and like there's crazy whole worlds of stuff you don't really need to worry about. Because if they're after you, something else is already wrong. Like, don't worry about that level of security. Worry about like
why they're trying to get you.
Yeah. So his idea is just don't think about it.
So just like
we're totally sidetracked now.
Yeah. Okay. We got off on a tangent that should have been long enough for the GitHub emails to show up. And
Everyone good with you good with the GitHub account now? Okay,
sweet.
Cool.
That was a fun
So-
tangent, though. I like security.
So now we're going to create our first repository.
Okay.
The plus sign in the top right after you've signed in, click on it and click New Repository. And it's going to prompt you for the repository name. The owner, you don't need to worry about. That'll just be you. You can add a description, which is optional. If you have access to private repositories, you can add them, but those cost money.
Or you can get
Unless you're
5
a
for free if you're a student.
Yeah,
So
we'll talk about that later.
I'm just going to mention, you don't need to memorize this. If you're part of an organization and you want to create a repo for that organization, you get this drop down with all the organizations you're in.
Yep.
I'm kind of in a lot of them. And then if you want to be able to clone it immediately, you should click that Initialize with a README box. Every repository should have a README. It should tell you what it is and what it does and why you did it. Even if it's a private thing, it's amazing. 6 months from now, you will have totally forgotten what the heck you were thinking. So be kind to your future self and write them documentation. Recurring theme.
Once wrote the Perl script. I have no idea when I wrote it or what I was thinking when I wrote it. I have no memory of actually even writing it, but I found it last year. I wrote it like 5 years ago. It has my name on it, so I think I wrote it. I have no idea. The documentation I wrote on it was really helpful though, so I was okay.
So, and then we hit our magical create repository button. And
it made a repository.
It made a repository. That's so cool. URLs are really easy to remember on GitHub. It's github.com/ the person or group that owns the repository / the repository name. And then if you gave it a tagline and a title, it'll really helpfully make the README with the title and the tagline.
Yep.
Do you mind if I go off on the tangent of the UI is kind of cool?
Yeah, go for it.
Okay, so there's some really useful things about the GitHub user interface. You can do a lot of the usual actions through the UI. This is helpful if you're working with less technical people, like maybe you're working with a businessy type on a collaborative project in a class who doesn't want to learn how to use Git. Maybe you're just doing a drive-by fix for a repo and you don't really want to clone this whole giant code base onto your system, but you want to fix a typo for them. You can edit the files through the user interface. You click on the file, and then there's a little pencil icon.
So GitHub will let you edit the files and actually add them directly to the repository from the web. Kind of neat. Most people who use Git a lot don't ever use this, but it's a really nice feature in a lot of situations.
So
It's also really nice for the README because it gives you a preview of what you're doing. And the README is actually written in Markdown, which means that you put in like the title is actually underlined with equal symbols. And it
So you
gives
can
you
see mine too. There's some equal signs right there.
it gives you a live preview. If you click on this, that'll show you what it looks like. And you have some other features.
and
in Markdown.
I'm going to put a section heading. I happen to know Markdown. I happen to know that underlining it like that will make it a small heading. But if I go to preview, it'll show me how that'll look. It's great if you're doing like tables or something.
If you don't know Markdown, don't worry. We're going to talk about it later.
Yep.
She's just showing you some cool things. And she's adding her commit through GitHub's web interface. The commit message is helpful. Imagine you have no idea what you're doing,
So-
what you just did.
First line should be, rule of thumb, less than 80 characters of just really short, concise summary of what happened in this commit. And then you can do a really long commit message. There is no limit on how long a commit message can be. Like, I have at times pasted huge sections of IRC logs into a commit message to explain why I did this thing. And then when I'm looking back on it in a few months, I look back and go, why the heck did I do that thing? I can look at that particular commit and go, oh, we had that conversation in that channel that I might have completely forgotten about.
I had a coworker in my previous job who wrote a 700-word commit message. It was like about a page. No. Yeah, 1-page single space, give or take.
You can write
more.
novels in these if you want to. If you need to, then do it. If you don't need to, don't feel obligated to.
Yep.
And then when you hit commit changes,
GitHub adds the commit for you automatically.
then hey, look, now the
Ooh.
repo has those changes committed.
So I'm going to digress away from Git and GitHub real quick. Did you guys, in the second session, talk about SSH and SSH keys? No? Doesn't sound familiar
Nope,
at all?
we did not.
Okay.
We briefly touched on the fact that SSH exists, and we've all used SSH with either PuTTY or
Vagrant
the
SSH.
command line to get into their Vagrant boxes and to get to shell.owned.oregonstate.edu to set up their IRC.
So one of the reasons I'm asking this is because GitHub allows you to send changes to the server through SSH, and it's a really nice way to do that.
So what's
Since we haven't
SSH?
talked about it, SSH stands for Secure Shell. It's basically a protocol for logging into a server remotely and securely. You guys all used it to log into your virtual machines, either through PuTTY or through Vagrant SSH, which just tells Vagrant to run the SSH command for you. We're going to talk more about SSH and Git at a later point in time. For now, let's show them an example of actually cloning their repository on GitHub. So has everyone made a repository on GitHub now? Yeah? Has anyone not done it?
If you have not, raise your
If you have
hand.
not rated, yeah.
Okay.
So you guys have accounts, right? You set up with GitHub?
You guys came in late, so.
Yeah.
Oh, did you guys come in late? Okay. We'll come talk to you in a few minutes.
Okay, so once you have a GitHub account, we can walk them through on the terminal. I just want to show you where you put them once you've got them.
No, we're not doing
No?
SSH keys right now.
Oh, no SSH.
Just,
Okay,
do
cloning.
it for
Cloning.
HTTPS
Okay.
and it'll prompt for user and password.
That's cool.
So now Emily has this great repository and she wants to clone it.
I've got
on
a
her
repo.
machine.
I want a copy of it on my machine so I can do cool stuff with it. So I'm going to click up here on the repo name to go to the main page of the repo from wherever I was. There it's got the README and stuff. Over here, see down here, it's got an SSH clone URL. I want the HTTPS clone URL right now because we're going to pretend like I don't have SSH keys.
We'll set up SSH later. It's much nicer to work with than HTTPS. But
And
for
then
now, click on the HTTPS button.
And then you click the copy to clipboard link because the web is a cool place. Pop open a terminal or a new tab. And then I'm going to type git clone. And then I happen to know the keyboard shortcut for paste. In this terminal emulator, I think it's fair to assume it will be Control-Shift-V. Otherwise, you can go right-click and paste. And then you hit enter, and Git talks to us. Cloning, counting objects, compressing objects, unpacking objects, checking connectivity. So when it says cloning into example, that means that now when I ls, I have a directory called example.
That directory wasn't there a minute ago. Git clone created it and put the repository in it. So if she changes directory to example, which is the repository that she just cloned, and types ls, you can
And
see
there's my
there's
README.
the README that she made in the web UI.
I tried to cat the README so I could see it on the terminal. Typed cat RE and hit tab, and it didn't tab complete. That tells me I'm doing it wrong. Everything's case sensitive. If it's caps, it needs to stay in caps.
Yep. And there it is. So that was how you clone. Now we're gonna make we're gonna make another commit and show you how to push it back to the
What
server.
do we want to do? Add a file?
Yeah, add a new file. Don't do that. Do it now.
Okay.
Show them.
I can create a file with Nano by giving it Nano and then the file name, Nano Bootcamp. And then Control X. Do I want to save the buffer? Y for yes. File name to write, Bootcamp. That's correct. So I'll hit enter. And then now I have a Bootcamp file. Hey Git, how are things looking around here? I have an untracked file. That untracked file is named Bootcamp. How could I track it? Git is telling me I could use git add. BOO tab, of course, because you want to tab complete everything.
so
Git
far, after the clone, all these steps are the same as what we showed you earlier. We're just going to do them again.
Git status. I have a staged file, but it hasn't been committed yet. And so if I type git push right now, nothing will happen. And so a commit takes files from the staging area, wraps them up with a message and a date and an author, and makes a nice, tidy little change set. And then you really want to wrap, like you don't want to do one big long line. It's better to have shorter lines because it makes it easier to read.
You don't need to worry about that too much right now. She's writing some useful documentation. She was back in 5 years and has no idea what she was doing.
And then I want to meta X. Why, yes, I do want to save the changes, so I'll hit Y, enter, and
There's a new commit.
Git status, and everything's up to date. So git log. Oh, hey, I've got 2 commits.
So this is the commit she made on the web UI, and this is the commit she just made now.
So now,
Oh, I see a colon at the bottom. I probably got to hit Q to get out. I did have to hit Q to get out. Now I got it.
If you go back to GitHub real quick,
Mhm.
you'll see
Where was I? Oh,
Okay.
here.
Yeah. And click on commits in the top left. Under that, I guess. Yep.
2 commits.
so you see there's still only 2 commits. The commit she added on her local clone in the repository is not on the server yet.
So if this laptop caught on fire right now, my changes would be lost. That's bad. I need to fix that.
So she's going to run the command git push. Just git push, that's it. Because of the way we cloned the repository, Git already knows where to push to. When you do git clone and then you copy that line, Git will know to push back to that same place
Oh.
you copied from. Because we're using
I screwed up.
HTTPS, GitHub prompts you for your username, so it's username for github.com, and then you enter your GitHub username, and it will prompt you for your password, which is now right here.
Which I typed in, but you can't see.
She typed her password and then hit enter, and it has some output here. Ultimately, you can see it says master pointing to master. That means she added a commit from her master branch and pushed it to master on GitHub. That's not super important right now, just means she added another commit.
We'll talk about branching later.
Yep.
Yeah, question?
I'm getting an error on Git push. In HTTP request failed.
Are you connected to what network? Has your Wow.
My internet's working fine. I pulled it.
Oh, the VMs have occasional issues with network connectivity. Wait, it pulled okay. That's weird.
No, I got a 4-3 for Git.
Yeah.
Huh.
I'll help
Interesting.
you in just a second.
Yeah. Okay. But now,
How about other people who try to push right now to their repository? You running into an issue too? Are you running into an issue or is it working? Oh, not working? I'll help you in just a second too.
so
But just to show you guys, now you can see there's 3 commits. She pushed her 3rd commit, now it's there, which is good. Now the server has it. If you were to run a git clone on a different machine, it would pull all 3.
So now if my laptop catches on fire, nobody cares because all of my changes are up to date. Another neat thing to notice, that name that shows up right there is taken directly from the Git config on the machine where the commit was made. Since I made this commit through the web user interface, it knows it was from me. But it thinks that that's from somebody else because the settings are different over here.
So we'll see what they have to say.
Yeah, Google made I use Google for GitHub HTTP.
Oh, use SSH. That's one.
Yeah, we haven't started them on SSH yet because we haven't talked about SSH yet. Because we are using no background knowledge. It's not true. Yeah. Well, they have their own repo.
Just change the SSL. Yeah, drop your SSL.
So if you go back to the and yeah, so take cat space tilde / .git.
Wait, you wanted to do the Git for the.
There's a file called Git Status.
So, this is no, I suspect it's just a word.
Actually, I just changed my name back after making the file. But I noticed in GitLog it was showing my name and it was.
If you're getting big, it's normal to put your full name as your name. It's just like, it's a way of taking responsibility for your code.
Has anyone successfully pushed to GitHub? Or we did? Cool. Good job. I don't know what you did
I
different.
think you may have to let Facebook.
Okay.
We had networking has been weird all day.
Yeah.
It would have been really good because in the future, let's ship them an image with like tree and stuff installed. Yeah. So for CDN,
Okay, that's really weird.
yeah, I'm wondering if we can talk about it.
We're having issues. I did just find a workaround. Right now.
So,
I was just, I found a workaround for the form. I went into .github/moving file, added in my username at GitHub, and then prompted for a password. But is it possible that's for your username and then your password?
Yeah. Josh just said that they've had issues up there as well, so it's an interesting problem.
And it is visible on the site.
Okay. Thank you. Quick announcement, if you're having the 403 problem, Nathan found a workaround where if you type git config-e, and then it'll have, I'll actually show you here. So git config-e, go like that, hit enter, and then it has.
So this config is different from what you ran earlier. It's a config for your local repository.
And then
Every repository has its own config. Once you get earlier local repository, specific one.
And then you put your GitHub username at github.com instead of just github.com for the URL. And then you save it. And this works around its inability to prompt you for username. GitHub has been having intermittent issues all day based on reports from the other track. So try the username trick. That has worked on two people who were having that problem in the virtual machine so far. So that may fix it for you. You'll know if git push succeeds.
Were we supposed to set up remotes and things? Because-
No, not today. We're not gonna.
Are we not pushing that code to GitHub?
We're pushing it to GitHub, yes. So
Okay.
if you pulled from GitHub, then you can push it to GitHub.
Okay, so they created two repositories.
They have created 2 repositories today. Yeah.
Okay, I just wanted to.
Yeah, we're not configuring their remotes. We'll teach them that later.
Okay, because,
The 403. Oh yeah. I'll pull it back up. So we append their GitHub username and the app side in the URL of the remote. And that fixes it.
And that's in,
Because Nathan is really good at Googling things. So we want to easily add. They're both bad things. What is the order bag? They're the Lord's bag too. I asked them. It analyzes your GitHub repository and finds people who are the only ones that touch the file. And they're like, oh, that's just accept my bug. I
What are we actually doing right now?
we are getting people and then after that, I'm announcing some stuff and then we're done.
I might have been better off. I didn't know about
And you already have actually
We're going to have some instructions on there before setting up the mailing list. That's what we're going to also click on the date camp link. So there's a button that says vote for the meeting time. We have decided meeting time. We're going to do it based on what works for everyone. This coming week, we're probably going to do something on Wednesday. Because that's it's going to be say no new next week. So if you want to get back up and you have questions, we'll go more stuff into that. I don't have a time yet, but still send an email about that. Could you register? So we don't have this. Because we're going to send out an email to everyone to register on step right to say
Okay, can I get your attention real quick? Could I get your attention real quick, please? Just a couple of announcements before we're done for the day for a little bit more help with Git stuff, and then you can go. So, hey, Murray. So we've got, this continues through the year. I know that today was a real whirlwind of way more new knowledge than you can possibly assimilate usefully. So the DevOps Bootcamp program is going to continue through the school year. We need to know what time of the week works best for you guys. So there's a doodle poll at osl.io/DODC for DevOps Bootcamp 2014. Go fill out that poll. I will send an email to everyone who registered for this event via the Eventbrite.
Who did not register via the Eventbrite? Raise your hand.
So
Okay.
we will get your email addresses before you leave. Give us your email address so we can add you to the mailing list and keep you in the loop for times and stuff on what to learn more. And then there's going to be another event coming up. Well, not really coming up, in like spring term on April 18th. It's called Viva Barcamp. It's an open source unconference. You'll hear about it probably if you're taking any CS classes. The Linux user group will be in your classrooms promoting it. What unconference means to us is people show up with a talk. Could be about anything. There's been talks about yoga. There's been talks about walking. There's been talks about how to rerun coffee. There's been talks about how to rerun beer. There's been talks about
Drawing
how
comics.
to build robots, how to draw comics, why programming is like the 7 sins. Just all these ridiculous things. You can give a talk to if you want to. Or you can just attend talks and get free food and maybe shirt. It's coming up on April 18th, so don't schedule anything else for then.
Yes, April. It's in spring term. We like talking about it early because we like to talk about it a lot. And the one we did in spring term is already gone, so we have to talk about the next one.
Yeah. So just to let you know, that's the thing. It's pretty cool. You get to hang out with a bunch of people who know more than even we do about all this open source stuff, and you get to learn from them. Good place to make friends, good place to make connections. If you haven't already arranged an internship by then, you'll meet a bunch of people who work at companies in the area.
Mozilla is notorious for coming and hiring all their interns.
Mozilla hires a bunch of interns from there. You meet people who work at other startups as well. You can meet people who just happen to work at like Google or whatever. If you want to talk to them, ask how to apply, that kind of stuff. So plan on coming to Barcamp is the moral of the story. You had a question? Okay. So that's all the official stuff we've got. We still have a little bit of time, so we will help you with Git. We'll help you with IRC if you need it. And if we don't have your email address yet, I will get out a piece of paper and have you give it to us so that we can keep you in the loop. Thank you all very much for coming, by the way. I know that spending an entire day of your weekend on this is a whole lot of work, but we really appreciate the effort that you've all put in today.
Feel free to give us feedback too.
I don't know. I'll just use my computer.
Thanks for coming. Yeah.
I'm trying to help someone. I don't quite understand the goofiness with the config file we're doing.
Oh, I'll show you the
Okay.
Personally, I feel like just add a Git remote, but
Okay. So
I
the
do it right
funkiness
now. Yeah.
is you just add the username at GitHub. That's all you have to do.
Yeah. Okay.
So
I
we-
added that, and we're still getting. We pushed. We got past the 403 error,
Okay.
and it wasn't reflected in the GitHub UI, like the web UI.
Okay. So you go click on commits. It's not there.
It's not there.
Yeah.
Like it shows. This is an empty. This is an empty thing. And like, the gallon formula from there.
I think having the third session was too much.
I think it was good. I think it's definitely, we should plan on covering all of them again. Maybe not even just a session, but like a few other sessions as well. The way I see it, I don't think it's necessarily bad to throw too much information as long as you go back and read it. I don't expect anyone to remember everything we said today. That would be insane. So I told everyone we're probably having a catch-up session on Wednesday. We're just going to email about that. We're kind of talking about the material, more the questions that. And yeah, so we're getting the emails of everyone who's not on the event, right? And we're gonna send invites to the teams.
I guess everybody that's had that, because we have the entire list, and we know if they want to sign up for the beginner.
Yep. So we're just gonna email people who didn't register so we can get that. And I do.
I think we'll have a decompress thing next week sometime.
Probably.
Especially the brown t-shirt.
Yeah. Thanks for going away. I mean, we're both like pretty
So I relented and I downgraded my 70K.
Yes, I win. Win.
But it still didn't fix the weird issues I think. But
So Lance updated to a new Chef DK that they released, which has Chef 12, pre-release of Chef 12, and everything's changed in Chef 12. So all week I've been like, hey, I'm pushing this really cool change, and Lance will comment, of course, doesn't work. Doesn't work. Here's my error. So I've been telling him, don't use Chef 12. So he finally relented, which means I would.
well, the problem I mean,
Until it's actually released, in which case, like,
yeah, it's like I feel like we almost need to grow our own Chef DK now.
yeah,
Because we need the newer Burke show, because otherwise now I'm gonna get all the weird like, what does this really mean?
Also, actually, just been considering, you know, the list of gems that people got for everyone to install as part of the setup. We can just roll all of them.
I mean, it's all public and we can push it.
I've been maintaining it for 4 months.
I mean, it'd be nice to use their newest branch, but not I don't know how difficult that is.
Not too bad.
That's what I'd like to do.
Pretty easy.
But yeah, I was trying to redeploy the OTest controller stuff,
Yeah, that went crazy.
and
The issue is she never created the commit on the web UI.
Oh, what?
She never created the commit on the web UI.
Uh-huh.
And so I walked her through that process of making the commit, which is why I was like,
Yeah.
and then we just did again. We tried to push, and it's still not being reflected on GitHub's side of the fence. And I'm slightly confused why. I would like to help her.
we were having issues with GitHub earlier today.
Oh, yeah.
In one of the sessions. This one was trying to push, and it was like, it literally just pushed you. I was putting an error message from the GitHub server itself, where it shows the app is like, data, GitHub. We're like, okay, push, error, push, work, okay. Yay, DevOps.
Yeah, the piece you talked to this track, which is what I've been at all day. Just felt like, hey, we're going to give you enough information so you can ask questions, and this probably won't stick. Which is, I think, a really key step to that, but just to make it fun.
And I was getting people on IRC, like, because then you're kind of part of
But still, you gotta remember, no, I'm on GitHub.
yeah.
Like, thing, server, set up that's like we're on GitHub, or we're on exactly, but like that's what I mean. It's like now they're aware of it. Now if we say check GitHub more often, they will know, oh, that's that means, or they'll be able to ask, wait, how do I log into that? Or how do I okay.
Yeah, also Emily,
Say what?
girl talk to yeah. No, yes, I don't
Again, it makes sense.
You know, at some point I'm gonna see that actually.
Memento, like
Yeah, as a memento, you get away from doing that. It's like you just go permanently have it as an actual tattoo. I won't realize that it's not.
don't forget to push.
You should make one of the notes like a tattoo.
Oh, that'd be terrible.
It's so weird. Not washing up. All the other ones are washing up.
It just says something benign.
Oh yeah.
You know, someone's birthday or.
Audio was like 45.
And I go play with them and they're like, what are you on there?
Yeah.
You are expressive.
So like, you want patience? Aw, I picked up some voice projection today. I don't know where, probably theater in high school or something. But talking at that, I know. It's like, I need to stop and hang out too.